Hi, today's lesson is in geometry. Today we will study lines and angles and properties of lines and the angles they form. So let's look at some lines and how they interact with each other. So by a line I mean a straight line. And if I have one more line which touches this line in one point, I call these intersecting lines because they have a point in common. But this doesn't always have to happen. I can have two lines that never touch each other. They move in the same direction forever and they never come closer or they never go far apart. Such lines are called parallel lines. You can have a third parallel. I can, of course, have a line going across them, and then this line intersects all three of those parallel lines. We shall study this scenario in much more detail. What about lines that intersect in a special way? So, suppose I have a line and another line that meets it at 90 degrees. Then these two lines are called perpendicular lines. What's special about them? That both sides of the vertical line make the same angle with the horizontal line. They in fact divide the horizontal line equally into two angles. These two lines are called perpendicular lines. Of course, this is just a special case of lines intersect. Angles. So how do we form an angle? Two lines intersect at a point, then the space between the two lines is called an angle. Another way to understand an angle, I take a line segment and I rotate this line segment around a fixed point. And the line segment ends up somewhere here. So I started the line segment AB and I rotated AB and it ended up here. I rotated about A. And I formed this angle. This is the angle formed by the rotation of AB. The point A is called the vertex of the angle. And often the angle itself is called angle A. The angle is named by its vertex. I could, however, name the angle using 3 points. I could have this vertex point as A, this point is B, and this point is C. And then I could name the angle as angle BAC or angle CAB. That means I'm starting at B, going to A, and then going to C. I'm starting at C, going to A, and then going to B, tracing out the angle. In both cases, the vertex is the middle point of the triad. BAC means A is the vertex. CAB again means A is the vertex. So when I rotate a line to form an angle, let me keep this as a reference point, and this rotation is less than 90 degrees, then it's called an acute angle. If the rotation is more than 90 degrees, it's called an obtuse angle. If the rotation is exactly 90 degrees, then it's called a right angle. And if the rotation is all the way around till I get a straight line, then it's 180 degrees and it's called a straight angle because it creates a straight line. So these are typically 4 kinds of angles we get: the acute, obtuse, right, and straight. Complementary and supplementary angles. So these are special pairs of angles that have been given special names because they occur very often. So again, I'll put my perpendicular as a point of reference to my horizontal line, and I'll rotate my line, say 30 degrees, And then I look at the other angle that I would have to rotate to get a right angle. So this angle would be 60 degrees. Let's name them A, B, C, and D. So then the angles BAC and CAD are complementary. That means they add to 90. Angle BAC plus angle CAD add to 90 degrees. So I could draw another one here. Let's call this EF. Then angles EAF, that's this angle, and angle FAD, that's this angle FAD, also add to 90 degrees, so they are also complementary. What are supplementary angles? Well, in the case of supplementary angles, they should add to 180. That's the difference. So if I go BAC and then I go CAD, so I've gone angle BAC and then I've gone angle CAD. And you can see that angle BAD is 180 degrees because it's a straight angle. Therefore, the two angles that make it up, this one and this one, are called supplementary angles. So angle BAC plus angle CAD equal to 180 degrees. So they're called supplementary angles. Simply put, angles that add to 90 are called complementary angles, and angles that add to 180 are called supplementary angles. Let's work out a problem. In the figure below, 2x is equal to y. Find the value of x. So what can you say about x and y? So if I go y degrees and then from there I go another x degrees, how many degrees have I covered? So I've covered 180 degrees because I've finally done a straight line. Got the straight line. So I know that y plus x, y degrees plus x degrees is equal to 180 degrees. That is y plus x is equal to 180. Y and x are supplementary angles. Okay. I'm also given 2x is equal to y. So in my first equation here, I can substitute 2x for y. So y plus x equal to 180 becomes 2x plus x equal to 180. That is 3x is equal to 180, which means x is equal to 60. Which again means y is equal to 2 times 60 is equal to 120. Of course, they've asked for the value of x, which is 60. So the answer is B. So the important thing to notice in this question was that y plus x was 180 degrees since it formed a straight line together. Vertical angles. So when two lines intersect, say this way, or even this way, or this way, then these two angles, which are opposite each other across the vertex, are called vertical angles. So these two angles are vertical angles, and these two angles are vertical angles. These two form a pair of vertical angles, these two form a pair of vertical angles. Let's look at some properties of vertical angles. So I have a pair of vertical angles. Let's call this A, B, C, D, E. So what can I say about angle? Let's call the angle BAC and angle CAD. Well, together they add up to 180 degrees. because they form the straight angle BAD. So if I call this x, then I should call this 180 minus x, because they add up to 180. Now look at this straight line, CAE. That means angle CAD and angle DAE also form a supplementary pair, because the angle CAE is also 180 degrees. So angle CAD plus angle DAE are also adding to 180. And I know that CAD is 180 minus x in my notation. So 180 minus x plus angle DAE is equal to 180. Therefore, angle DAE will be 180 minus 180 minus x. I distribute the minus sign and I get x. So this angle also turns out to be x. That's interesting. If I continue working, I'll get this angle also turns out to be 180 minus x. So what do I see? I see that the pair of vertical angles are equal. So I see that angle BAC is equal to angle DAE. These are vertical angles. So they are equal. That's what we proved. Vertical angles are always equal. It simply follows from the fact that the straight line always makes 180 degrees, and each of the vertical angles is supplementary with a common angle. So for instance here, angle BAC and angle DAE were both supplementary with this angle, with angle CAD. So they turned out to be equal. Which of the following statements must be true? A equal to D. Is that true? Well, this angle and this angle are vertical angles. And we've just seen that vertical angles are equal. So yes, this statement is true. A plus C equal to 180. A plus C. That forms the straight line. So yes, they are a pair of supplementary angles. They are equal to 180. A plus D equal to 90. A plus D equal to 90. Well, there's no theorem that states that vertical angles add to 90. Vertical angles don't need to be complementary. And since no values are given, I can't confirm this. So this needn't be true. They've asked which must be true. So only statements 1 and 2 must be true. C. Parallel lines cut by a transversal. Okay, so here's where it gets a little interesting. So we saw earlier that parallel lines are lines that move in the same direction, never meeting and never diverging. They're generally denoted by showing an arrowhead in the same direction. What's a transversal? A transversal is a line that cuts both of them. So this is the basic scenario. We could of course have a third parallel line cut by the same transversal. So there are many angles formed, as you can see. This angle, this angle, this angle, this angle, this angle. So we're going to look at properties of these angles and how they relate to each other. The important thing here is that these three lines, L, M, N, are parallel. So let's look at the first set of angles. So I have my parallel lines and I have my transversal. This angle and this angle are called corresponding angles, or this angle and this angle. These pairs of angles are called corresponding angles. And since these lines are parallel, corresponding angles are equal. That follows from the fact that these lines are parallel. Lines are parallel if they are inclined the same way. So now this line, the transversal, meets the first parallel line L, making such an angle. So it should meet the second parallel line M, also making the same angle, because the lines L and M are inclined the same way, being parallel. That is in fact taken as a definition of parallelism. That if you have a transversal and if it makes the same angle with both lines, then the two lines must be parallel. If it doesn't make the same angle with both lines, then the two lines are not parallel. So if corresponding angles are equal, then that proves the lines L and M are parallel. And conversely, if the lines L and M are parallel, then the corresponding angles are equal. Interior alternate angles. Let's see which angles these are referring to. So firstly, they are interior. That means they are within the two parallel lines. These are the interior angles that the transversal makes with the parallel lines. Interior alternate. That means they are on different sides of the transversal. So this pair is a pair of interior alternate angles. Let's call it angle A and B. And this pair is another pair of interior alternate angles, angles C and D. A and B, C and D. So let's understand the terminology again. They're interior because they are within the two parallel lines, and they are alternate because they are on opposite sides of the transversal. There is the transversal and they are on opposite sides of the transversal. So the two pairs of interior alternate angles we have are A and B and C and D. And they are equal when the two lines are parallel. The corresponding cases, exterior alternate angles. So here are my two parallel lines, L and M. Remember, these were the interior angles. These will be the exterior angles, these four. Let's call them A, C, B, D. Again, exterior alternate, so on opposite sides of the transversal. So A and B are exterior alternate angles, and C and D are exterior alternate angles. They are outside the two parallel lines and on opposite sides of the transversal. Again, they are equal if the two lines are parallel. If L and M are parallel, then the exterior alternate angles are equal. And conversely, if the exterior alternate angles are equal, then L and M are parallel. Same side interior angles. So interior, these are the four interior. Same side of the transversal, so this and this. So this is A and B or C and D. So again, A and B, C and D are same side interior angles. We're given that L and M are parallel. Now what's the property? Well, we know that A is equal to D because those are interior alternate angles. So we know that A is equal to D, interior alternate. But D and B add up to 180 degrees because that's a straight angle. So we know that D plus B is equal to 180 degrees. And now D is equal to A, so I can substitute the D by A, which implies that A plus B is equal to 180 degrees. And that's the property of same side interior angles, that A plus B add up to 180. A plus B equal to 180 degrees, or C plus D equal to 180 degrees. They are supplementary. A neat way of saying it is, same side interior angles are supplementary. Of course, all this only holds if L and M are parallel. And conversely, if same side interior angles are supplementary, then L and M must be parallel. Okay, let's use all this information in some problems. In the figure above, L and M are parallel. Y is equal to, this symbol means parallel. This means L and M are parallel lines. Find Y. So basically we need to identify Y and the 70-degree angle. We've just seen that Y and the 70-degree angle are within the two parallel lines, so they're interior angles, and they're on the same side of the transversal, so they're same side interior. And we know that same side interior angles are supplementary, since L and M are parallel. So I know that 70 plus y must equal 180. That means y is equal to 110 degrees. The answer is C. So the calculations are of course very easy once you've identified the angles. In the figure above, L is parallel to M. What is x equal to? So we need to relate x and the 150 degree. Well, x is an exterior angle and the 150 degrees is an interior angle. And I don't know any theorem where x and 150 on opposite sides of the transversal get related. So let me relate the 150 to an easier angle. So if this is 150, this must be 30 degrees. So this is a straight line. Now this angle, the 30 degree angle and the x degree angle can be related. They are corresponding angles. They are on the same side of the transversal. Transversal makes the same angle with both the parallel lines. So I know that they are equal. So x is equal to 30 degrees. A. So this was a slightly more difficult question. The 150 degrees and the x degrees could not be directly related. But using the supplement of the 150 degrees, I got to this angle, the 30 degree angle. And then it became easy to relate that to x. They were equal. Find the value of y. Line P and line Q are perpendicular. So P is perpendicular to Q. And I'm given this 40 degree angle. Let me see if I can use it. I'll try to move towards the y degrees. So the 40 degree angle and this angle are vertical angles. So they are equal. So this also turns out to be 40 degrees. Now I know that line P and Q are perpendicular. So this whole angle is 90 degrees. That means 40 degrees plus y degrees is equal to 90 degrees. The 40 degree angle and the y degree angle are complementary. Now we are done. Y must be 50. C. Find the value of y. L parallel to M, P parallel to Q. So here we have two pairs of parallel lines and they are transversals to each other. Notice that P is a transversal to the LM pair and L is a transversal to the PQ pair. And similarly for M to PQ pair and Q to the LM pair. So we have lots of parallel lines and lots of transversals. Okay, the first thing I notice is that X and 3X, what are my parallel lines here? P and Q are my parallel lines and they're cut by transversal L. So if P and Q are parallel lines cut by transversal L, then the X angle and the 3X angle are same side interior angles. They are on the same side of the transversal L and they are within the parallel lines P and Q. So they are interior. And what we know about same side interior angles? We know that they are supplementary. They add to 180. So x plus 3x is equal to 180. 4x is equal to 180. X is equal to 45. The question is to find y. Now that I know that x is 45, I got to relate it to y. So using x, I can find this angle. This angle is 180 minus x. So 180 minus x is 135. 135 degrees. Now this angle and the y degree angle can be related. We have two parallel lines L and M and the transversal P. So let me draw it again. L and M transversal P. This is 135 degrees and I need to find this. L and M are parallel. What are these two angles called? Well, they're outside the two parallel lines, so they're exterior. and they're on opposite sides of the transversal P, so they're alternate. And what we know about exterior alternate angles? They're equal. That means Y must equal 135. So it's E. Important question, because we used different pairs of parallel lines and transversals, first to get the value of X and then to relate that to the value of Y. Find the value of X plus Y. So here we are given three parallel lines, LMN, cut by two different transversals, T1 and T2. We're given an angle 40 degrees and we're given an angle 60 degrees, and we got to get to the angles X and Y. So let's start moving. So I'll use the parallel lines L and M and the transversal T1. So this is 40 degrees. So this will be 40 degrees since they are corresponding angles. Now if this is 40 degrees, this will be 40 degrees since these are vertical angles. Now this is 40 degrees. Look at this. Look at these two parallel lines. M and N cut by transversal T1. So the 40 and the Y are same side interior angles. So 40 plus Y must equal 180. So Y is equal to 140 degrees. I found Y. Let me repeat it. Look at L and M transversal T1. L and M transversal T1. If this is 40, this is 40 by corresponding angles. Having got this far, this 40 and this vertical angle must be equal. So this is also 40. Then I have these same side interior angles. If this is 40, then it's supplementary to the Y degrees. So 40 plus Y is 180, Y is 140. Let's do the same thing for the 60 degree angle. If this is 60, vertically opposite, this is 60. If this is 60, corresponding, this is 60. Here lines L and M cut by transversal T2. If this is 60 and this is X degrees, again they are same side interior. So 60 plus X is equal to 180. X is equal to 120. What's the question? Question is, what is X plus Y? That's 120 plus 140. That's 260. In the figure, P parallel to Q parallel to R, which of the following statements is not true? A plus E equal to 180. A plus E clearly equal to 180 because they form a straight angle. A plus E form a straight line. True. D equal to E. So D is here, E is here. So we have two parallel lines P and R cut by this transversal. Let's call it L. And these are exterior alternate angles. D and E are exterior alternate angles. So they are equal. True. C equal to B. C and B. We have two parallel lines Q and R cut by transversal M. And B and C are clearly corresponding angles. This transversal makes an angle B here, an angle C here. So true. B is equal to C because they are corresponding angles. A plus D equal to 180. So I got to move from A to D. This is A. So A must be 120 because it's vertically opposite this 120 degree angle. So this A is 120. This must be 60. Same side interior angles are supplementary. That means these two angles add up to 180. If this is 60, this must be 60 vertical angles. And if this is 60, D must be 60 corresponding angles. So A is 120, D is 60. 120 plus 60 is equal to 180. Yes, A plus D is equal to 180. What about C plus D? Interesting. So if this is 60, I know that this is 120. Now these two angles, this 120 degree angle and this C degree angle are corresponding. Are they equal? Is C equal to 120? Well, no, because L and M are not parallel. That's the catch. It is not given that these two angles, L and M, are parallel. We have only been given that P, Q and R are parallel. So I cannot assume that these two corresponding angles are equal. I cannot assume that. This and this are not equal because L and M are not parallel. So C is not equal to 120. And so C plus D will not equal 180. So E is not true. Very important question. If the lines are not parallel, none of the theorems about equality of angles holds. Remember that. You have to be given parallelism.